So, what if we could actually read your mind? I don't mean just guessing what you're thinking. I mean literally decoding the electrical signals firing inside your brain. Yeah, it's not science fiction anymore. We're diving headfirst into neurotechnology, the science of reading from and maybe even writing to the human mind. And let me tell you, it is forcing us to ask some of the biggest, deepest questions about who we even are.
I mean, just stop and think about that for a second. For the very first time in history, we have tools that can directly connect to our minds. This is real. This is what's allowing people with paralysis to communicate just by thinking. It's the technology that holds the incredible promise of treating diseases like Parkinson's. The power we're unlocking is, well, it's the power to reshape what it means to be human.
But with all that incredible power comes a huge question, right? As we start picking apart the machinery of our own thoughts and our own identity, are we even remotely prepared for the ethical minefield that's waiting for us? Because here's the thing, the technology is moving at an absolutely breakneck speed, and it's leaving our rules and our ethics completely in the dust.
So, to really get a handle on this, we need to understand something deeper than just the tech itself. We have to look at how the science behind it all actually gets made, because this isn't just about cool new gadgets, it's about a whole new way of understanding ourselves.
So, what are we really talking about here? We're talking about things like brain-computer interfaces, BCIs, and deep brain stimulation. These are actual devices that can monitor your brain activity, figure out what you're trying to do, and even change your mood or your personality. We are literally directly touching the hardware of the human soul. Now, okay, before we get lost in all the ethical questions, we actually need to take one step back. To really get the challenges of neurotech, we have to ask an even more basic question. How does science even work? How is scientific knowledge built? And trust me, it's not nearly as neat and tidy as you probably think. This classic idea from the philosopher David Hume really gets to the core of it. See, science isn't about finding absolute 100% final proof. You could see a million white swans, one after another, but that still doesn't prove that the next one you see won't be black. And what that means is that all scientific knowledge is basically provisional. It's built on theories that have been tested really, really well, not on some kind of unbreakable law.
So if science isn't about total certainty, then how on earth does it move forward? Well, three key philosophers give us the tools to figure this out. You can think of Karl Popper, Thomas Kuhn, and Imre Lakatos as our guides for understanding how scientific ideas live, change, and sometimes even die.
First up is Karl Popper, and his big idea was something called falsification. He basically said a theory is scientific not because you can prove it's right, but because you can try your hardest to prove it's wrong. A really good theory makes risky predictions. It puts its neck out there. And its strength comes from surviving every single attempt to knock it down. But then along came Thomas Kuhn, who argued that scientific progress isn't always so gradual. He said science usually operates inside a dominant paradigm, like a shared rule book that everyone agrees on. But over time, little problems or anomalies start to pile up until the whole thing just doesn't work anymore. That crisis leads to a scientific revolution, and boom, a totally new way of thinking. And finally, you've got Imre Lakatos, who kind of blended these two ideas together. He saw science as a collection of research programs, and these programs are built around a central, protected, hardcore belief, an idea that researchers just will not question. And to protect that core idea, they build a really clever set of defenses. So every research program has this hardcore belief at its center. Then, to defend it from attack, scientists create what he called a protective belt of smaller, disposable hypotheses that they can change or get rid of if an experiment doesn't work out. The big question for Lakatos is whether the whole program is progressive, meaning it's successfully predicting new things, or degenerating, where it's just making up excuses for why it's failing. Okay, philosophy class is over. Now that we have our philosopher's toolkit, let's use it on the truly mind-bending challenges of neurotechnology. This is where all that theory gets very, very real. All right, so using Lakatos's model, what's the hardcore belief driving neurotechnology? It's pretty simple, actually. The idea that the mind is what the brain does, that all our thoughts, our feelings, our consciousness, it's all at the end of the day just physical stuff happening in our skulls. This is the absolute central idea the entire research program is designed to protect. But this program is already hitting some big problems, some anomalies. A perfect example is the reverse inference fallacy.
So, say a brain scan shows your amygdala lighting up. We know the amygdala is involved with fear, so it's super easy to conclude, aha, this person must be afraid. But that's a huge, flawed leap, because the amygdala also lights up when you're excited or curious or even happy. It shows this massive gap between seeing brain activity and actually knowing what someone is feeling.
And the anomalies aren't just technical things on a chart. They're deeply, profoundly human. Just listen to this quote from a patient after they received deep brain stimulation. "I miss being me." Wow, it's just heartbreaking. The technology can change someone's personality so much that they feel like a stranger to themselves. They just don't feel like them anymore.
And this is a perfect example of what Thomas Kuhn was talking about. Experiences like that create a huge crisis for our old, comfortable idea of what a self is. Neurotechnology is forcing a paradigm shift, a revolution in how we even define personhood. It's suggesting that maybe our identity is way more fluid, way more like a story we tell than we ever thought possible.
And the challenges just keep coming. Think about agency, your ability to be in control of your actions. Well, brain-computer interfaces create this weird thing called distributed agency. Basically, you have the intention, but a computer algorithm is what actually carries out the action. So when something goes wrong, who's to blame? It's exactly like when your phone's autocorrect sends a totally disastrous text message. Was that you? Or was it the machine?
And all of this leads to a fundamental threat to the one place that has always, always been private, our own minds. The fact that we can now start to decode thoughts has sparked this revolutionary call for a whole new legal framework, a new set of human rights called neurorights. These are rights designed to protect our cognitive liberty, things like the right to mental privacy and the right to control our own identity.
So, faced with these gigantic challenges to our identity, our agency, and our privacy, where do we go from here? How do we build a future where this incredibly powerful technology actually serves us without, completely undermining what makes us human?
Well, the best place to start is to just listen to the patients. They are pointing out the biggest gaps. Seriously, what happens if the company that made your brain implant goes bankrupt? Who is on the hook for your care 10 years down the line? These are not abstract philosophical questions. These are urgent problems that need real answers right now.
And a huge part of the solution is to just stop treating ethics like some annoying roadblock to science. Instead, these frameworks for studying the ethical, legal, and social implications, they call it ELSI, they need to be seen as a true partner in the research. Ethics needs to be in the lab from day one, helping to guide the science, not just judging it at the finish line. So the main point is this. If we want to build what Lakatos would call a progressive research program, one that actually moves us forward, we need some really clear principles. We have to demand total transparency. We need to create new ways to help patients deal with these massive changes to their identity. And we absolutely must figure out who is responsible for the long haul so no patient is ever abandoned.
Which really leaves us with one last massive question. This technology gives us the power to edit and rewrite the very code of human experience. So the challenge for every single one of us is to figure out, as we do that, how do we make sure we protect the author?